Here comes question number 6. From now on, the questions will become slightly tricky. It's not that they are very difficult, but you might have to use certain tricks to solve them. And from now on, for every question which I am going to solve, I will try to write down the tools which I will be using to solve the problem. Let's look at the question number 6 now. We have to prove cot A plus cosecant A minus 1, the whole thing divided by cot A minus cosecant A plus 1 equals 1 plus cos A divided by sin A. I'll write down the tools which I will be using to solve this problem. So this is my toolkit. I must thank Academy for making me ambidextrous. So I'm going to use 1 plus cot square theta equals cosecant square theta. The same thing can also be rewritten a couple of different ways. For example, you can write this as cosecant square theta minus cot square theta equals 1. And let's interchange. That is cot square theta minus cosecant square theta equals minus 1. Okay. Next, I want to talk about what is known as conjugate. If you have an expression like a plus b, its conjugate would be a minus b. And a minus b's conjugate is a plus b. So this is the conjugate. Okay? And in mathematics, very often we use what is known as multiplying and dividing an expression with its conjugate. Okay, let's come to this question. I'm going to rewrite this in a slightly different way. Cot A plus cosecant A minus 1. I'm going to put a bracket here. The whole thing divided by cot A minus open a bracket. Then you will have cosecant A minus 1. Since I have opened a bracket here, this minus and minus will become plus. So this will have cosecant A minus 1. Both are one and the same. Now, I'm going to multiply by cot A plus cosecant A minus 1, which is the conjugate of cot A minus cosecant A minus 1. I'm going to multiply and divide by the conjugate of the denominator. That means multiply by cot A plus cosecant A minus 1. Whole thing divided by the same thing. Basically, I multiplied by 1. It doesn't change, right? If you look at it, the expressions are conjugate of each other. Now, let's multiply this out. So, this equals cot square A. This is nothing but A plus B whole square formula, right? So, cot square A plus cosecant A minus 1 the whole square plus 2 cot A multiplied by cosecant A minus 1. The whole thing divided by cot A minus cosecant A minus 1, cot A plus cosecant A minus 1. So this is the form A minus B multiplied by A plus B. So the formula which you will use is A square minus B square. So this is cos square A minus cosecant A minus 1 the whole square. Okay. Now, next step. We have cot A, another cot square A. Cot square A can be written as cosecant square A minus 1, right? So, cot square A is, so cot square theta is cosecant square theta minus 1. That's what I'm going to use here. So, I'm going to use this. Okay? So, this can be written as cosecant square A minus 1, right? So this will be cosecant square A minus 1. Then you have plus cosecant A minus 1, the whole square, plus, I won't keep this expression as it is, 2 cot A multiplied by cosecant A minus 1, the whole thing, divided by cot square A minus, let me multiply this out. So cot cosecant square A, cosecant square A minus 2 cosecant A, okay, plus 1. Now, let's remove this bracket. If I remove this bracket, this will become plus, so this will become minus, right? I just remove the bracket. I've not done anything else. And multiply the minus throughout inside the bracket. Now, cosecant square A minus 1. Cosecant square A minus 1 square, right? So this can be written as cosecant A plus 1, cosecant A minus 1. Cosecant A plus 1, cosecant A minus 1, right? So we will keep this as it is, plus cosecant A minus 1, the whole square, plus 2 cot A cosecant A minus 1, the whole thing, divided by, now you have cot square A minus cosecant square A, that is cot square A minus cosecant square A is minus 1, we have here. So cot square A cosecant square A, so these two combine together and gives you minus 1, right? So you have minus 1, so minus 2. 2 cosecant squares, or rather 2 cosecant A. So this you will have 2 cosecant A minus 1. Okay? Now, let me factor out cosecant A minus 1 in the numerator. Cosecant A minus 1. I'm factoring out cosecant A minus 1. So you will have cosecant A plus 1 open a large bracket. Cosecant A plus 1. Okay. Here I factored out cosecant A minus 1. So you will have cosecant A minus 1 the whole square. Factor out cosecant A minus 1. So you will be left out with 1 cosecant A minus 1. So plus cosecant A minus 1. Close the brackets. Okay. Now, okay, we'll keep it like this. So 2 cot A cosecant A minus 1. See, I could have factored out this also, but I just want to go a little slow. Whole thing. So you have 2 cosecant A minus 2 rather. No, 2 cosecant A minus 2. So you have 2, factor out 2 here. So cosecant A minus 1. You see a pattern emerging, right? So you have cosecant A minus 1 everywhere. So in the next step, we all will cancel out and give you this expression. So let me write down the next step here. Okay? So you have cosecant A minus 1. You have this plus 1 minus 1 getting cancelled. So you have 2 cosecant A. So cosecant A minus 1 multiplied by 2 cosecant A plus 2 cot A multiplied by cosecant A minus 1 divided by 2 multiplied by cosecant A minus 1. Everything will cancel out nicely to give you this answer. Okay? Now the whole thing divided by 2 multiplied by cosecant A minus 1. Now, you have this 2 get cancelled. So you have 2 here. That is, if you factor out 2, that 2 will get cancelled with this 2. Similarly, factor out cosecant A minus 1 from everywhere. This get cancelled. So finally, you are left out with cosecant A plus cot A, which equals cosecant A is 1 by sin A, correct? Plus cot A is cos A by sin A, okay, which is equal to 1 by sin A. Take sin A is common. That's common denominator. So you have 1 plus cos A. Okay, so this is what we want to prove, right? So Q E D, that is for error demonstrator. Okay, so this is what we want to prove. Let's go to question number 7.